foremost, because we're talking about isosceles triangles, you're going to draw your triangle. You need to know that two of those angles need to be the same. So two of those angles will be the same. And then that third angle needs to make sure they all add up to equal 180 degrees. So draw your isosceles triangle. Think, what do you want your two angles to be equal to? And then what does that third one need to be to make sure all three of them add up to equal 180 degrees? So take a moment. One more time.
120 plus 30 is 160, right?
120 plus 30 is 150.
So it needs to be.
So if your other two angles are
60.
well, then in order to get 80, is that on top of the triangle anymore? So we can't do 60.
So it'd be
90 for your other angle? Well, 90 plus 90 is 180, but then you don't have any room for your third angle. Okay, you can do 80 for both of them. And what does that make your third angle? So what were some angles we thought of? What were some things we put down for our isosceles triangle?
Bless you.
Thank you. What were some things we came up with?
64.
64 degrees?
64.
Good. So that's one possibility. 64, 64, 52. You could really put a lot of things in here. And then, did you have the exact same thing you asked for? Isosceles triangle. But once again, isosceles triangle, two of those angles are the same, two of the sides are the same, and then your third angle just needs to make sure they all add up to equal 100 degrees. Second little warm-up thing we're going to do, thinking back to the very beginning of the year, we talked about naming angles and what type of angles, which angles we're talking about when we were given these angle names. So if I'm talking about angle ABC, what would be the measure of angle ABC? 45. How do you know that, Morgan?
Yeah.
Because
Other two of them are getting the same.
So if we look at the letters and go in order of the letters, it's A, B, C. So we're talking about this angle right here.
Middle one. So it'd be
So your middle letter is always the vertex of your angle. That one's 45. Because the middle letter, so B is always the vertex of your angle. So it's A, B, C is this angle right here. So 45.
So we're not trying to find what angle C.
Well, we will need to eventually find what angle C is. So what if we're asking for angle ACB? What's ACB? How do you know? How can we figure it out?
Oh, you gotta add up the other two.
We can do 180 minus 58 minus 45, and that should give us, I think, 77 is our answer. Because we know all three of those triangles have to equal 180, so minus your other two, and that's left with your third. That's angle ACB. And last one, angle CAB. CAB leaves us with 58 as our. Are we okay with this? So once again, the middle letter is always your vertex, so that can help you determine which angle you're talking about. But when you have multiple angles hold next to each other, using the same vertex, sometimes you need those three letters. So I'm going to hand out this little card matching thing. So on this, your goal is to find all of your missing angles. So you have you have 6 triangles, A, B, C, D. Your goal is to find all of those missing angles of your triangles using our knowledge of all those angles add up to equal 180 degrees. All of them are what are your exterior angles. But here's the thing, all of those 6 triangles are isosceles triangles. So we know isosceles triangles, 2 of those angles have to be the same. So on those first two, where it has those two hash marks on those angles, those represent them being the same. So isosceles triangles always have two angles that are the same. So your goal is using your knowledge that all of them are isosceles triangles, that they all have to equal 180 degrees, and your knowledge of exterior angles being equal to your opposite two angles. See if you can find all your missing angles of each of your triangles. And then from there, you should get 3 pairs of triangles. So A will match with another triangle, B will match with another triangle, C will match with another triangle, and based off their angles will all be the same. So if A has 64 and whatever these two are, there will be another triangle that has like 64 and whatever the other two angles are.
Just these, not the.
Yes, yeah, just worry about the front for now, those 6 triangles.
Okay.
So take a moment, see if you can figure out what those are, and then we'll look through them together just a bit. Okay, so looking at these 3, what did we find for the first one? How did we go about that?
58.
So you got 58?
Yeah.
How did you figure that out?
Because you take,
180.
yeah, 180 minus 64 and divide that into like 2.
So we know both of these are going to be the same, so we can take 180 minus 64, so they'll split equally, so we can divide by 2, and get this 58 for both of them. What about this one over here? How do you for that? B.
180 minus 114 gives you that one with the 66. Then do 180 minus 66 divided by 2.
That should be 57 each. Good. Good. All right. What about C? How can we find that one? Gabe, what did you do for C?
You took the outside one and minus the 1.
So 180 minus 121 gives you 59.
Yep.
And then from there, 180 minus 2 minus 59 gives you 159, I think. Your third angle. Good. What about D?
You've got to take 180 minus 123 and divide that by 2 because it's both going to be the same and add up 57 both times. And then take that, so that, 180 minus that ends it up to 66.
So you can do 180 minus 123 gives you 57. You can do it. We know that's going to be the same for both of them because they're both 123 on the outside. And then 57, or 180 minus 57 minus 57 gives you 67. And then our last few is sort of cut off a little bit. Same idea for this one. So you have 2 different exterior angles, so 180 minus 118. That gives you 62. 180 minus 121 gives you 59. And this one should also be 59, I think. So 180 minus 62 minus 59. Last one, it's already easy. You're given 2 angles for you. So 180 minus 58 gives you 64, I think. And those should be all 3 of your angles. So what pairs did we find? What one was paired with A? B, D, and then C. Nice. Those should be. So finding which triangles match through pairs isn't really important at the moment, but it's something we'll talk about later on when we talk about triangle congruence and triangle similarity. Triangles having the same angles can be important later on. And so each of these were isosceles triangles. And so something unique about isosceles triangles is that if you have 2 sides in an isosceles triangle, so any side triangle that has 2 congruent sides, that also means that both of those angles have to be the same as well. Specifically, it's the opposite angle. So the opposite angle of AB is the angle with the vertex that doesn't touch it. So this opposite angle would be C of AB. The opposite angle of BC would be the angle that doesn't touch it, which is A, or the angle that includes it. And so this is a base angle theorem. So we sort of just accepted this, that isosceles triangles always have 2 angles that are equal. But this is really important because not only does it say that if I have if any triangle that has 2 sides are the same, you can automatically assume which 2 angles would then also be the same because of that. Any triangle that has two angles are the same, it works both ways. Any triangle that has two angles are the same, you can automatically assume which two sides of that triangle will be equal to each other. So this base angle theorem, even though we sort of always accept it as true, has a lot of power to it. We can use it to help us prove some things. And we can use it to help us solve some of these triangle problems that we might run into. And so this is a new theorem we're going to add on to our other two that we talked about yesterday. So our interior angle sum of a triangle is always 180 degrees. That was one theorem. Exterior angle theorem was another one. The exterior angle equals the two other angles added together. And so this is our base angle theorem, which are isosceles triangles. If two sides are the same, two angles are the same. And vice versa, if two angles are the same, two sides are the same. And then the last one we're going to talk about tomorrow is our mid-segment theorem, which we'll get to tomorrow. But let's look at this PowerPoint still. So let's look at some of these problems. This is on the back of your page. So in case you didn't pick it up, these hash marks here, these little hash marks on your triangle, those are telling you the sides are the same. So any triangle with those hash marks say these two sides are the same. If it had double hash marks, it would be the same as another one with double. So they always have to have the same. Those are just different ways of mathematicians denoting which triangles are, which sides are the same or which angles are the same. Same thing with these little arcs. So these little arcs have doubles. That means both of these arcs are the same as well. So those are just some little things to look for when given a problem. Yes, Morgan?
So it's usually the two at the top. I like the top.
Not always up.
Not
Because
always.
say this triangle was upside down, like this, now it's called these two sides are the same. It might be these two angles are the same. Or say my triangle was like this, and I'm told these two sides are the same. My two angles are always my opposite ones. So opposite of this is over here, opposite of this. So it's not always there's two bottom angles. We just write it that way just because it looks nicer. But it's not always the situation. Sometimes those triangles might be turned around and flipped around. So it's good to know which angles are the opposite angles of your triangles. So it's always the vertex that's not touching that side. Yeah, okay. So let's see if we can figure out all the missing angles from this triangle using our base angle theorem. So right now, the only thing we don't have any angles. We just have these two expressions that fall into these spots. But due to our base angle theorem, because we know both of these sides are the same, we can say both of these angles are the same. There are opposite angles. That means 8x minus 16 is equal to, is congruent to 6x plus 4. So they're congruent to each other. From here, we can solve just using our algebra. I'm going to get all my x's to the same side, all my constants to another side. It's easier to get up into my lower side, so I'm going to subtract 6x to get it over to my left side. That's 2x minus 16 equals 4. Plus 4. Equals 4. I need to get my 16 over because I want to get all my constants on the other side. Two-step equation, so add 16. And this is the last time. Alright, so that gives me 2x. These cancel out. 4 plus 16 is 20. Divide by 2. I get x equaling 10. Now that we know what x is, we can plug that back in and we can get all of our other angles. So I got x equals 10. I'm going to plug that into this expression just because it's a little bit easier. So that means 5 times 10, no, 6 times 10 plus 4. 6 times 10 is 60, plus 4 is 64. I can do the same thing and plug it into my 8x minus 16, but I don't have to because I know these two angles are the same. This one's 64, this one's also 64. 64, 64, that makes my third angle 180 minus 64 gives 52. And that is our three angles. Once again, basic angle theorem works both ways. If I have two sides that are congruent, I have two angles that are congruent. But it works the other way. If I have two angles that are congruent, I have two sides that are congruent. So I can use the base angle theorem on this as well. Because I know my two angles are congruent, I can say x plus 2 equals 3x minus 4. My two sides can be congruent as well. Same idea. So get all your x's to one side, all your variables to the other. Or I'm sorry, all your x's to one side, all your constants to the other. So I'm gonna give my x to the side that has the larger x. That cancels out. So that's 2 equals 2x minus 4. Add 4 to get my constant over my two-step equation. So that gives me 6 equals 2x divided by 2, divided by 2, x equals 3. That's our x. In order to solve for my side lengths, I can just plug it back in. So I can plug 3 in for x. 3 plus 2 equals 5. If this side equals 5, this side also has to equal 5. If I really wanted to, I could check it by plugging it back in. Are we okay with these problems? So this base angle theorem can kind of help us solve some of these problems that we might run into. A lot of these triangles, though, some of these triangle problems are like little puzzles. So they're like little puzzles. You have to get one piece, and that can help you find the next piece, which can help you find the next piece. And so one of these issues that we might run into is just being able to discern what can I glean from this information, or how can I solve these little tricky questions. So with these two problems, we want to find the value of x and y. So in this first one, I have 3 triangles sort of like connected together, and I'm told this side is the same as this side, same as this side, this side, same as this side. A lot of sides. They're all congruent to each other. We need to find x and y. What can we do? What can we do on this problem? What do you notice about the middle triangle? So we have 3 triangles up there. What do you notice about the middle triangle specifically?
They're all the same.
All the sides are equal. What type of triangle is it called that? And what do we know about equilateral triangles? They're all 6 degrees. So this must be 60. This must be 60. Hey, so if they're all 60, we solve for x. That's one piece. Good. One now. Where can we go from there?
All their sides are equal.
Well,
Yeah, because like the 2 sides,
are they all equal?
like the 2 other sides will be 60 because they're the same.
So we know, because this is an isosceles triangle, that these 2 sides are the same. And because this is an isosceles triangle, these 2 sides are the same. Because they're both the same. By our exterior angle theorem, all of these triangles, all these angles are the same. On all of them. So we know how much is this full group right here? This full middle group. How much does that make? 180. So all 3 of these angles added together is 180. So if I do 180 minus 60, gives me 120, divided by 2, that gives me 60 for each piece. And then from there, that gives me this is 60, this is 60, this is 60, this is 60. So they just all happen to be equilateral triangles, but you need to make that connection with the first one and these 2 are the same before you can go on from there. Good. All right, let's look at that second one. So we have 2 triangles put together. Together, they make a right angle down in this column. And then we are told this side is the same as this side. We have 40 degrees, and we're trying to find x and y. What can we do on this one? Angle next to 40. So this one right here. What do you know about that? So these are supplementary together. So what does that make this angle? 180. 140, we can take 180 minus 40 gives us 140.
So
Okay.
get it to a 20.
So good, because that's 140. We know these by our base angle theorem are equivalent, so we can do 180 minus 140 divided by 2 gives us 20 for each of these. So we know what x is. What do you think y is 50? So this whole right angle isn't in this triangle though. Because this little sliver right here, 20 degrees of that right angle, is in this triangle. So we have this.
So that one's 70.
So yeah, we can say that the rest of this angle is 70, and then we can find it out by 140 or 40 plus 70 gives us 110, which makes this angle y 70 degrees. Then you can actually figure out that these are 70, and these are the same size. Those are also. You got some more there, but that's not important. Good. So that's where we'll